RAM or memory, both are same. Okay, physical server, this is 1000 GB local disk. Now, when you create a virtual machine, if you allocate 4 GB RAM to, so here everything we allocate virtual RAM, let's say 2 vCPU and 50 GB virtual hard disk. And a virtual machine, everything we assign virtual resources. It's not direct, right? It's not physical. Physical is on ESXi host. So the physical resources available here, RAM, CPU, hard disk, will be on the physical server, which is on ESXi host. The resources which we have allocated here to the virtual machine, they are virtual, splitted from this quantity and allocated here. So here, if you allocate 4 GB RAM from 100 GB, it will be 96 GB available on the ESXi host. Okay. Same way, hard disk also 1000 minus 50. But CPU, here you can see 2 vCPUs. We can give like 10 vCPUs also. Okay. But here we have only 1 or 2 processors, maximum 2, maximum 4 also will be there. But 90% cases 2 CPUs. And here we allocate like even 8 vCPUs also. How the processor will be split or virtualized from the underlying ESXi host, we'll try to understand. So if you see virtual machine, if you go to its edit settings, everything is virtual here. The CPUs, RAM, hard disk, network adapters, CD divide, everything. These are all virtual hardware. It's not physical. They are separated from underlying ESXi host, RAM, CPU, and hard disk. The quantity of RAM and hard disk is directly minused from the total capacity here. Okay, we'll see the CPU now. And one more thing, once you power on, anyway, hard disk, we will not use it from the local hard disk. It will be coming from remote storage, SAN storage. If you power on this computer, then only it will use this RAM and CPU. If you power off, again on ESXi machine, you will see as 100 GB RAM. If you power on only, this will consume, this will take this RAM and CPU. Even 2 CPUs or 4 GB RAM, if you power on this computer only, it will take from here. If you power off, it will not use. You will see as 100 GB only, not 96. You can create one more VM, you can give. Okay. So all together on powered on virtual machines, only you need to count the usage. You can give like maybe 120 GB RAM, let's say 80 GB RAM here, 4 GB RAM here. Another machine, some 20 GB RAM also, let's say 15, let's say 18 GB RAM. If you power on all together, then will be a problem, more than 100%. Okay. If you don't power on this machine, if you power on only these two, 98 GB RAM, that's still okay. Okay. So you can create VMs, but the matter of like how many VMs you are powering on and quantity of RAM usage on the powered on VMs only matters. Clear? RAM and CPU. Hard disk it will not give back. Hard disk is data stored on it, so it will be there only. Only RAM and CPU. If you power on the VM, then only it will consume from this ESXi host. Clear? If you see our host also 240 summary tab, here you can see how much memory it utilized. Out of 64, 42 GB RAM is used. But if you see all virtual machines, There are 88 virtual machines and RAM usage. I want to see like how much of RAM we have allocated here. It's not visible as of now. What I'll go on the same window, this window icon, click on it. You can see memory size. Enable it. Here you can see. All together. Here you can see somebody given 50 GB RAM just for the ESXi host. Okay. All together it will be more than 100 only in this case. Even beyond 200 GB is there. If you want, I'll show you the calendar. Click on export. You can get Excel sheet of this report. Just VM's list. Okay, this is memory size. We'll count it. $462 GB. Okay, and total we have it is 64 only. Okay, I think we are using 8 times of it. But total usage is like 42 GB only because all machines are powered up, so it's not taking that much time. If you power on all of them, then it will be gone. Our lab will be down only. It's too much. Understood? RAM and CPU will be utilized only when those are powered on condition. Hard disk, always it will be there. Now we know RAM and hard disk, how they will be splitted from here and allocated here. Now we'll see the CPU thing. To understand CPU, we need to go back to some of our computer basics schooling. There is a motherboard. Okay. If you open motherboard and tell me like how many of you have physically seen a motherboard? Just raise your hand if you have seen motherboard. Nobody? In our lab, it's there. Okay. Okay, just like this. It will be there like this. Okay, if you open your laptop or a desktop or a server, it will be like this. There are a lot of other components we connect here. Like here, these 4 slots will be used for RAM. RAM chips will be like this. It will be like this. This will be having a quantity like 4 GB, 2 GB, 8 GB, 16 GB, 32 GB also. Single one. Okay. So if you buy like 2 into 32 GB, it will make 64 GB. Okay. Like these kind of chips will go and insert here altogether. That makes total quantity. Then here it's the processor chip that we place here. It's called socket. Okay. This rectangular design where we have, right, it's a socket. There is a specific portion where we can insert a chip. It's called socket. On top of this, we go and insert a processor chip. If you go to images, this one CPU means, as of now you are thinking about this box, right? Forget it. Like even we discussed on, I think, second or third day. CPU means don't think about this box. CPU means this chip. Okay, i5, i7, i3 chips are there. You can see here this small chip. This chip will go and insert on this motherboard socket. Motherboard socket. So one is already inserted here and locked. You can see if they have locked it also. If it is empty, it will be like this. You can see empty slot here. Okay. empty slot. Right now there is nothing is inserted. Once you insert this chip, it will be inserted. That is called socket. Okay. Now we have inserted one small processor here, which is called CPU. I'll say CPU is already inserted. Take this one and just I'll overlap just to understand we have inserted that. Let's say just keep inside it. Okay. Processor is inserted now on this socket. Now here how many sockets we have? One socket only on this computer. All your personal computers, laptops and desktops comes with one socket only. Okay. And now we have inserted one processor. Now let's consider this is very old processor. Before Core i3, i5, i7, the processor was like Pentium 1, Pentium 2, Pentium 3. Started with Pentium as I know. Okay. Processor, very old processor. Okay. How this processor will work? Let's say you are trying to send some 5 calculations to this computer. Okay, some 5 instructions you are sending at a time. So they will be executed one after the other. That means one. Okay, all the 5 instructions are in the queue. First, this processor will execute first instruction. Once that is completed, then it will be second, then it will be third, and it will be fourth and fifth. One after the other, it will execute. Clear? ఒకదాని తర్వాత ఒకటి instruction execute అవుతుంది. First one execute అయ్యేటప్పుడు second one will be waiting. When the first one is executing, second one will be in the queue. Okay. So like this, let's say it will take 5 minutes to complete this work. Each instruction will take 1 minute. So all the 5 instructions will be completed after 5 minutes. Because they are in 1 minute, 1 minute it will take for one instruction. They are in the queue. So after 5 minutes, all will be done. This is how they used to work. And this processor, earlier they used to call, they have only one core. One core means one processor. Socket means the location where we insert the chip. That chip is one core. One chip means one processor is equal to one core. I'll say one small chip of processor. One core, okay, which is one processor like this, one processor. It can execute one instruction at a time. Clear? One core, one socket and one core. It's clear, right? How it used to execute. Any questions from remote? Core and socket. Okay, good. Now, after and up to Pentium 4, P1, P2, P3, P4 processor, it was like this only. Some improved algorithms to make it faster, but the same process, one after the other, it will execute. After that, the processor technology has evolved. They made something called dual core processor. That means processor is one only, one core, one processor only as of now, but internally it has algorithm of 2 processors. Okay. Internally it's divided into 2 parts, but if you look at this processor, it looks like single chip only, but inside its algorithms are separate. So it's like it works exactly like 2 processors. మనకు చూడడానికి ఒక చిప్పే ఉంటుంది, బట్ రెండు ఇన్స్ట్రక్షన్స్ ఒకేసారి ఎగ్జిక్యూట్ చేయొచ్చు because it's a 2 processors. The algorithms inside, the working mechanism inside is doubled. That means if you send 5 instructions, first instruction will execute here. At the same time, this is a second CPU, right? Second processor will execute second instruction. First instruction will go here at the same, something like you are going to bank, there are 2 counters. Instead of waiting in the queue, you will go to the next counter. Okay, it's like that. First instruction will execute here, second one will execute here at a time. So both will execute at a time. So if you see dual core processor, by the time of executing all these 4 instructions, it will be 2.5 minutes only. Because they are executing parallelly. రెండు ఒకేసారి ఎగ్జిక్యూట్ అవుతుంది. ఇంతకుముందు అయితే ఒక్కొక్కసారి ఎగ్జిక్యూట్ అవ్వాలి. Understood the logic? Okay. So 2 instructions are executing at a time on 2 processors. Physically it's 1 processor, but inside it has mechanism of 2 processors. So 2 instructions are executing at a time. So now in this computer, how many sockets are there? 1 socket. Cores? How many? Dual. Dual means 2. Okay. 2 cores. 1 socket and 2 cores. Here the same work was taking 5 minutes. Here the same work is completing in 2.5 minutes. Understood? Now, dual core, initially when they introduced dual core, it was working fine, but not that efficient. Correct gaane work avutundi gaani manam expect chesinanta performance kuda raaledu. But the logic was correct, but it was not working properly as that much they expected. They changed it to core 2 DO. They've improved their algorithms, same logic only. They made it as something called core 2 DO, same 2 cores only, some improved algorithm to make it efficient. Correct ga work avvadaniki logic correct, but working mechanism koncham delay unde, some issues, bugs unnai, you can say, like there were some bugs in the execution. They fixed it and they made it called like core 2 DO, 2 cores only again. Okay. Now, after this i3, i5, then i7, now i9 also evolved. Okay, just a minute. Hello. Okay, sorry for that. Okay, so the after that i3, i5, i7, nowadays i9 also is available. Okay, so these 2 processors again they logically splitted into 4s. Now how many socket, how many cores? And 4 cores. 4 instructions at a time will execute. Just 1 minute, 1.25 minutes, this work will be completed. Clear? But same single chip only. If you see, it will be a single chip like this. But the same work will be completed within a minute of time. Understood? It's 4 core. And there are processor with 8 cores. i7 will be 8 cores. i5 itself will be 8 cores. Now my laptop has i5 processor. Okay, I'll show you how it looks like. The processors are splitted. This computer properties, you can see i5 processor, right? Core i5. We'll see like how many processor it will show. Okay, now we'll see how many processor it will show. To see our processor, just go to task manager, which is a real-time processor performance analysis tool. Okay, CPU, task manager in your Windows computer is the tool where we can see its real-time performance analysis. For processor, we get something here. It's not showing some options. This Windows, they will be updating frequently and some changes will bring. Just a minute. It will show you all 8 processors. That's what I wanted to show. But where? Okay, let's change it here. If you see here, CPU 0, CPU 1, CPU 2, CPU 3, 4, 5, 6, 7, 8. So total 8 processors it's showing. But inside my laptop, there is only one chip like this, i5 processor, and it has 8 cores. And that information you can see here only. You can see here, one socket and 4 cores. Physical cores are 4 like this only. Okay, one socket and 4 cores. But why it is showing 8 processors? We'll see. We'll discuss about that. It's showing 8 processor. If you see here, resource monitor, it is showing from 0 to 7. CPU 0 to CPU 7. So that means 8 processor it is showing. But actually 4 cores. I'll tell you the reason. We'll go to that topic also, because that feature is already enabled. That's it. Okay, one socket and 4 cores, and it is clearly you can see in the properties. Then i7 will have 8 CPU, 8 cores. i9, I'm not sure how many cores, but 8 only, some increased efficiency only. They made it faster than i9, but 8 cores only will be there. But in server processors, you will see 12 cores and 16 cores also. One socket and 16 cores also it's available. Understand, right? Like 16 instructions at a time they can execute. As of now, you understood the socket versus core, right? Okay. And all personal computers comes with single socket only. And cores will be different, like 2, 4, 8 will be there maximum. Personal computers. Server computers starting with single core, but all production servers, it will have 2 sockets. All servers, physical servers, there will be one socket also. But most of them, 95% of the servers will be 2 sockets. In this case, 2 sockets are there. And cores will be, depends on how many cores you have on each one. If it is dual core, 2 sockets and 2 cores each. Let's say dual core, both are dual core only. Now, 2 sockets and 2 cores. So total how many cores we have here? 2 sockets into 2 cores. 4 cores will get, because 2 sockets, right? Ikkada 2 untai, ikkada 2 untai. Total 4. Okay, something like that. If you are not sure, this one only I am saying. Here there are 2 cores on socket 1 and socket 2 also. There are 2 cores. Total how many cores in this computer? That's what I have written here. Okay, 2 here and 2 here. And now what if 4 here, 4 here? Now how many cores? 8 cores. 2 sockets and 4 cores each into, like 2 into 4, it will be 8. It's clear, right? 2 sockets into 4 cores each. 8 cores total. It's clear? Cores and sockets and total. On laptop, if you want to verify, just go to task manager and processor. Here you can see how many sockets, how many cores you have. Don't look at logical processors yet. ఇంకా చూడండి, దీని గురించి రెండు కన్సిడర్ చేయండి as of now. 1 socket and 4 cores. Okay. On physical ESXi machine, select your ESXi host, summary tab, hardware. Here you see an option called hardware, expand, processor, expand. 2 sockets and 8 cores here. In our physical server, 2 sockets and each one has 8 cores. Total how many cores? 2 into 8 only. Same logic, 16. 16 cores we have. Okay. Clear? So this core refers to one virtual CPU. On a virtual machine, if you go to edit settings, right? you're able to assign 2 CPUs. That means it has 2 cores. Up to 2, you can assign maximum 16. If you in this server, maximum 16 processors you can allocate to a single VM. 16 processor. That means this total number can be maximum 16 only, because 16 cores are available here on the ESXi host. Clear? Maximum 16 virtual processors on a virtual machine on this specific ESXi host as of now. Okay, ippati varaku. Clear or any question? We'll go little multiplication. Maybe you will feel complex. That's why I'm asking now. ఇంకా కొంచెం మల్టిప్లికేషన్స్కి వెళ్తాం. ఇంకా nothing critical, just multiplications ఉంటాయి ఇక్కడ. But you may feel complex. As of now, ఈ basics అర్థమైంటే ఇంకా నెక్స్ట్ వచ్చేది కూడా ఈజీగా అర్థమవుతుంది. Okay. Now we understood cores and sockets and total cores how to count. And total count refers to maximum vCPUs on the virtual machine. Okay. Now, thing is, if you install ESXi operating system, if you install like Windows or Linux, it will be same. If you install ESXi from one core in the latest version, say from starting from 6.0, 6.5, 6.7, 7, 8, all 32 virtual CPUs it will generate. From single core, we can use 32 vCPUs. As of now, 16 only we can allocate, right? Once you install ESXi here, we can allocate 32 vCPUs from single core. But we have total 16 cores. 16 into 32, maximum. This is product maximum. Nobody will use maximum. How many vCPUs we can generate here? Even I'm bad in calculation. I'll just count. How many? 16 into 32. 512 virtual CPUs. 512 vCPUs we can allocate to all the VMs that we create here. Clear? ఒక కోర్ నుంచి 32 vCPUs జనరేట్ చేయొచ్చు ESXi ఆపరేటింగ్ సిస్టమ్ ఇన్స్టాల్ చేసిన తర్వాత. అదే విండోస్ కానీ లినక్స్ కానీ ఇన్స్టాల్ చేస్తే 16 కోర్స్ మాక్సిమం యూజ్ చేయొచ్చు. ESXi ఇన్స్టాల్ చేస్తే 512 vCPUs యూజ్ చేయొచ్చు. బికాస్ ఇట్ విల్ స్ప్లిట్ one core into 32, or it can serve one core to 32 vCPUs, or it will split one core into 32 vCPUs. Clear? These vCPUs we are allocating to the VMs. ఇక్కడ స్ప్లిట్ చేస్తే వచ్చే ప్రాసెసర్ కౌంట్ ఇక్కడ యూజ్ చేస్తున్నాం. క్లియర్? అండ్ ఇన్ డే టు డే జాబ్ ఆర్ ఈవెన్ ఇంటర్వ్యూ, your colleague, nobody will go to this much depth to discuss. మీకు ఎక్కడ ఇది ఇంత డెప్త్ గా తెలుసుకోవాల్సిన అవసరం కూడా ఉండదు. జస్ట్ ఫర్ యువర్ నాలెడ్జ్ హౌ ద ప్రాసెసర్ ఈస్ సపరేటెడ్ ఫ్రమ్ ద అండర్లైన్ ఫిజికల్ సర్వర్. జస్ట్ ఫర్ యువర్ నాలెడ్జ్ పర్పస్. Understood? Okay. So as per product maximum 32 vCPUs, but nobody will consider 32 vCPUs. In my infrastructure, we are considering one core 6 processor. Right now it is 6.6 that we are considering danger. 6.6 itself, it is giving performance issues. Virtual, many customers, like many people who are using VMs will complain that my VMs are slow. Can you help me to fix that problem? Because the CPU allocation is 1:6.6 as of now. That itself is leading to performance issues. Preferred value, we are preferring at least one core for 4 vCPUs is some stable value. 1.6 itself is performance issues. If you say like 1.32, definitely customers will stop working because machines will not work at all. Just product allows you, but we cannot guarantee this much good performance up to 32 CPUs. Okay. Product support చేస్తుంది కానీ 6, 7 యూస్ చేస్తే 1:7 యూస్ చేస్తేనే పర్ఫార్మెన్స్ ఇష్యూస్ వస్తున్నాయి ఫ్రీక్వెంట్ గా. ఓకే, సో మనం 32 యూస్ చేస్తే డెఫినెట్ గా ఆ VMs వర్క్ అవ్వవు మోస్ట్లీ. బట్ ప్రోడక్ట్ సపోర్ట్స్ టు అలొకేట్ like this. Clear? Understood? 1:4 is some stable value we are considering. It's up to company, how they're what application they are running. That also matters. If it is less application intensive, small applications, it will 1:8 also may be better sometimes. Okay. So, and you don't need to decide about these factors. Your day-to-day job look వెళ్ళి మనం ఇంతే ఉండాలని చెప్పాల్సిన అవసరం కూడా ఉండదు. Okay. You don't need to worry about it. Just for your rough calculation. How can you say like 32 vCPUs can ESXi gives? Official documentation, VMware documentation. 2 CPU and 4 vCPU. Almost you can say like that, Shiva, not a problem. Yeah, I can say yes. Okay, VMware maximums. You have to use something called VMware maximums or VMware vSphere maximum. Okay, so you get a URL from VMware website itself, and there is something called third-party website. This one, whatnet.net. They give directly instead of we manually go on here check them. This website directly will give you the numbers. You can see here virtual CPUs per core. You can see here. This is third-party website. You don't need to believe this. We'll go to official website, but as a single page, we can see all of them here. Older days, ESX1, 8 vCPUs, 1 core, it used to give only 8 CPUs. From 4.0, 20, 4.1, 25, 5.5, 5.0 to 5.1, 25. 5.5 onwards, it's 32 here. Even 8.0, there is no improvement because 1:4, 6 itself, we are getting performance issues. Okay, 1:7 itself, we are getting issues. If you make more splitting, it will be a lot of performance issues. That's why they are not improving now. They improved from 8 to 32, they stopped it. Okay, virtual CPUs per core. The same thing you can check from VMware official web. This is the official website, vmware.com. You can see. Okay, official website itself. Virtual CPUs per core 32. Which version? vSphere 7. If you select 8 also, it will be same. Here, vSphere 8, virtual CPUs per core 32. Okay. Clear? Any question as of now? Now I'll give you some just calculation how many VMs you can build on a single host. Okay. Okay, now consider there is a host. Okay. It has 100 GB RAM. Okay. One socket, 2 cores. If you install ESXi on this ESXi host, I'll show you one example how it looks like. Then you have to tell me the second one. Listen carefully. Okay, next one I'll ask question. I want to understand how many virtual machines I can build on this ESXi host. I have 100 GB RAM, 1 socket and 2 cores. Okay, and each virtual machine, if you create a virtual machine, each virtual machine should get 4 GB RAM and 2 vCPUs. Okay, with this specification, I want to understand how many maximum VMs I can build. To find it in real time, you don't need to calculate this. It will be provided by a separate tool. The same calculations will be there in the tool. ఇది మాన్యువల్గా చెప్తున్నా నేను, అది ఆల్రెడీ ఆటోమేట్ చేసి టూల్స్లో ఉంటాయి. మనం జస్ట్ నెంబర్స్ ఇస్తానే ఎన్ని VMs ఫిల్ చేయొచ్చు అని క్లియర్గా ఇచ్చేస్తుంది. బట్ హౌ ఇట్ విల్ బి క్యాలిక్యులేటెడ్, జస్ట్ బేసిక్ నాలెడ్జ్, రైట్? Okay, I have to allocate 4 GB RAM to each virtual machine. I have total 100. That means 100 divided by 4. How many VMs? So with respect to RAM, I can build 25 VMs. As